So here we're just going to recap an introduction to the normal distribution. So there are some features of the normal distribution that we must be aware of. The normal distribution is probably one of the most popular distributions within statistics, within mathematics, and that is because it is a naturally occurring distribution which we get in nature, which we get in the population of people. It just occurs on a regular basis. If we were to measure the heights of 14-year-olds, they would adopt a normal distribution, with the majority of those 14-year-olds having a height close to the mean, with very few of those 14-year-olds being extremely tall, and with very few of those 14-year-olds being extremely short. And this is just true for lots of different things. If we were to measure the lengths of leaves, if we were to measure the amount of rabbits, or if we were to measure people's estimates, if we were to measure so many different things, they tend to follow a normal distribution where the majority is located close to the mean, and there are two similar tails, which leads to symmetry. Okay, so the features that we want to discuss are the bell curve, so two tails and a peak in the middle. This leads to the next point, which is symmetry. So the normal distribution is symmetrical. This is going to be a very powerful feature as we continue with our work on the normal distribution. Being symmetrical means there is no skew. And if you remember previously, we could determine skew by the location of the mean, the mode, and the median. So interestingly, the mean, the mode, and the median of the normal distribution are all located in the same place. So this blue dashed line should represent the mean, the average value, the mode, the most popular value, and the median, the middle value. All right, so this is a condition, or this is a property of the normal distribution. And next, the fact that the area under the curve represents a probability of 1. We're going to use our normal distribution for problem solving based around probability. And a key fundamental point is that the area underneath this curve, which we could have found through integrating, is going to total to 1. So the area below the mean is 0.5, and the area above the mean is also 0.5. So that's a starting point, but we're going to look at lots of other ways that we can split up this normal distribution graph and find other differing probabilities. Okay, so 3 aspects, 3 properties, 3 characteristics of the normal distribution. It has a bell curve, it's symmetrical, and the area under the curve represents the probability of 1. Another underpinning characteristic of the normal distribution is that actually this is true for continuous distributions. The normal distribution is a continuous distribution. I'll draw some more emphasis onto that in a little while.